In this video, I will discuss chi-square test of goodness of fit. What is chi-square test of goodness of fit? This is a test of difference between the observed frequencies and the expected frequencies. Let's take an example, the theory of Mendel regarding crossing of peas. According to Mendel's theory, the yellow color is dominant over green. And in terms of skin, smooth skin is dominant over wrinkled skin. In this case, the theory, which is the expected, is compared with the actual experiment, which is the observed. How do we use the chi-square test of goodness of fit? We use the formula x squared is equal to the summation of the quantity O minus E squared divided by E, where x squared is the chi-square test, O is the observed frequencies, and E is the expected frequencies. For example, a certain machine is supposed to mix peanuts, hazelnuts, cashews, and pecans in the ratio of 4:3:2:1. A can containing 500 of these mixed nuts was found to have 270 peanuts, 110 hazelnuts, 80 cashews, and 40 pecans. So these are your observed frequencies. At 0.05 level of significance, test the hypothesis that the machine is mixing the nuts at the ratio of 4:3:2:1. Solving now by stepwise method. First is to identify the problem. Is the machine mixing the nuts at the ratio of 4:3:2:1? Then, formulate the hypothesis. First is the null hypothesis. The machine is mixing the nuts at the ratio of 4:3:2:1. Next is the alternative hypothesis. The machine is not mixing the nuts at the ratio of 4:3:2:1. Then, we have the level of significance. Alpha is equal to 0.05. The degree of freedom is equal to h minus 1. So, h here is the number of samples. So, from the example, we have 4 types of nuts. Therefore, that is 4 minus 1, which is equal to 3. And for the tabular value, that is chi-squared at 0.05. So, we'll be using the chi-squared table. As we can see on the table, on the leftmost part, we have the degrees of freedom, and then on the upper row, we have the levels of significance. So we need to locate the level of significance at 0.05, then the degree of freedom, which is 3, then get their intersection. Therefore, the tabular value is equal to 7.815. Next will be the statistics. As we can see, we have here a table of data from the example. From the first column, we have the nuts. Second column, we have the ratio. Third column, we have the observed. And we have the fourth column, which is empty. We have the expected. For expected, we need to divide the total observations by the total ratio. So all in all, we have 500 peanuts. Sorry, we have 500 nuts. then divide it by the total ratio. So we have 10. 4 for peanuts, 3 for hazelnuts, 2 for cashews, and 1 for pecans. That is equal to 50. Then, let us get the expected for peanuts. So that is 50 times 4. Since 4 is the ratio for peanuts, that is equal to 200. Then for hazelnuts, that is 50 times 3, which is equal to 150. Cashew will be 50 times 2, which is 100. And pecan is 50 times 1, which is equal to 50. So we already have the following data. Now, let us solve it using the formula x squared is equal to the summation of the quantity O minus E squared divided by E. First, we have the data for the peanuts. So we have the observed frequency for peanuts, which is 270, the expected frequency of 200 divided by the 200. Next will be the hazelnuts. The expected is 150 and the observed is 110. Just substitute it on the formula. Next will be for cashews. The observed is 80 and the expected is 100. Then for pecans, we have the observed of 40 and the expected of 50. Then evaluate it further. That is now equal to 24.5 plus 10.667 plus 4 plus 2. Then chi-squared now is equal to 41.167. Next is the decision rule. If the chi-square computed value is greater than the chi-square tabular value, this confirm HO. Then, formulate the conclusion. The chi-square computed value of 41.167 is greater than the chi-square tabular value of 7.815 at 0.05 level of significance with 3 degrees of freedom. So the research hypothesis is confirmed, which means that the machine is not mixing the nuts in the ratio of 4:3:2:1. It implies that the machine is not in good order because it does not mix the nuts as expected. That is chi-squared test of goodness of fit. Thank you for watching and I hope you have learned something.